All right, problem number 3 in chapter 3 on specific gravity. This is going to be our first encounter with the notorious Pound's formula. We're going to use the same concept that we used in the first two questions, which is knowing what the density of water is and using that specific gravity of 1.0 to calculate an unknown specific gravity based on being able to calculate how many pounds of water would be in an equivalent number of gallons. So the Pound's formula, which you will find on your sheet and which you will be intimately familiar with by the end of this class, is flow in million gallons times concentration, solids concentration in milligrams per liter times 8.34. And in cases of calculating pounds of sludge, you would also add times specific gravity. I'm going to put that in a different color just so it stands out. Times specific gravity. Most of the Pound's formula equations that we're going to be calculating will have to do with activated sludge, and you won't need to worry about specific gravity because it will be assumed to be 1. But in any event, when specific gravity is involved, you have to include that in the equation. So flow in million gallons, and that's important. We have to convert flow into million gallons times milligrams per liter times 8.34. So let's go ahead and take a look at our story problem. Let's look at what they're asking for. They are asking for specific gravity. So anytime I see a question asking me for specific gravity, I'm going to assume that I'm ultimately going to be comparing whatever liquid is being described to water, which has a specific gravity of 1. So just like in question number 2, what I'm going to do is calculate the number of pounds for a liquid with a specific gravity of 1. And then once I calculate that number of pounds, I can compare it to the pounds given for this unknown sludge, and dividing sludge pounds, if I divide that by pounds of water, that will get me to specific gravity. So at this point, we just have to plug the numbers in. So flow in million gallons. Well, where do we find that flow? Well, we're given a number of 30,000 gallons. We have to convert that to million gallons. And we would do that by dividing 30,000 gallons by 1 million gallons. And if we do that, we can rewrite this number as 0.030 million gallons. So it is 30,000 is 3% of 1 million, or 0.03. We can write this number as 0.03 million gallons, and we need to do that to plug it into the formula. So let's go ahead and do that. 0.03 million gallons. And again, this is you're going to be thinking about large numbers in flow in terms of million gallons. That's quite common in wastewater, so don't worry if it seems a little strange right now. You'll be getting used to it because you'll be doing it a lot. So the next number that we need to know is concentration in milligrams per liter. we're given that, so we can plug that into the formula. 13,000 milligrams per liter. And then our constant is the weight of 1 gallon of water, 8.34 pounds. So let's multiply this out. 0.03 times 13,000 times 8.34 equals 3,253 pounds of sludge, or I'm sorry, 3,253 pounds of water, or 3,253 pounds of water, or as we said, a liquid with a specific gravity of 1, which would be equal to water. So now we can do our final calculation, which is to divide the pounds of sludge, which we were given, 3,900 pounds of sludge, divided by pounds of this other liquid, which is the same density as water, 3,253 pounds of water. And if we do that division, 3,900 divided by 3,253, we get an answer, if we round up, of 1.20 specific gravity. So that's how to think about that problem and how to do it. Problem number 3.